today I'm going to solve another problem. This time, so we have slope deflection method in frames with Sidesway this time. Okay, so we're going to analyze this frame ABCD, fixed supports, and the lengths are not equal, so the frame is unsymmetrical. At the same time, the load of 40 kilonewton is applied not at the midspan. So on this example, it is very obvious that sidesway will occur. Okay, so usually sidesway occurs if the load is not symmetrically applied, or usually not at the midspan, and also if the members are unsymmetric. So for that case, sidesway is possible. So how do we analyze frame with sidesway? Okay, so first let us draw the frame with sidesway upon the imposition of the sidesway. So what will happen to the frame considering sidesway? So initially, before the application of the 40 kilonewton load, this is the original position of the frame. Okay, so when we say sidesway, it's the movement or the lateral movement of the frame sidewards. I mean, it could be to the left or it could be to the right. So most likely, since this one is longer than this length, so we could assume that the sway would be on the left. Okay, so let us assume that the side sway is on to the left. So if that happened, so the elastic curve would be, let's say this one. Okay, so member AB moves to your left, and member CD, let's say, move to your left as well. Okay, then the member BC will just be deflecting like that. Okay, so for that case, the horizontal movement of joint B, this one, let us call it as delta, say X. And the movement of joint C from here to this point, the horizontal movement, and let us call it as delta X. Delta X here is the same with delta X here, because we are assuming that there will be no axial deformation for member BC. So the length of member BC remains the same. So whatever movement of joint B here will be the same with the movement of joint C here. So therefore delta X, the delta or the sway at this joint would be the same with the sway of this joint C. So they're just equal to delta X. Okay, so if that would be the side sway, so if we take a look of what would be the sign convention for delta X, if you could recall, the sign convention for delta X is that it would be positive if it is counterclockwise, and it would be negative if it is clockwise. Okay, so if you look at this figure, originally member AB is here and it becomes this one. So the movement is from here to that point. Okay, so that is counterclockwise. So therefore, we have a positive delta here. Likewise, at this case, this is joint B, and the movement is on here. So the movement is, the rotation is on counterclockwise as well. So we have a positive delta on here. Likewise, on member CD or DC, so originally this is DC, and it moved counterclockwise from left, from this point to the left, so it moves counterclockwise. Likewise, this one, from here it moves to this point, so that is counterclockwise also. Okay, so what I'm saying is that the sign convention for delta would be positive since it produces counterclockwise rotation. Okay, now, so let us write the fixed end moments or the FEMs. So what are the FEMs? Okay, for member AB and for member CD, both doesn't have load. So therefore, the FEM there, okay, the FEM on member AB, it is also equal to the FEM on BA, okay, would just be 0 because there's no load. Likewise, for member CD, the FEM on CD, the same with the FEM on DC, since wala namang load ulit dyan, so that would be also 0. Now, what about for this member BC? Okay, so for member BC, so here's the member BC. Okay, then we will make it fixed at both ends. This time, the load is not placed at the midspan kasi it's 3 meters here and this is 4 meters. So let's say this is P, and this is distance A and this is distance B. And of course, the total span is L. Okay, so we could derive for the fixed end moment here by the equation that we have used before from the slope deflection method. So ayan, this one. So we can use this equation to solve for the fixed end moment. Or if you want, you can also use any of the classical method that we have learned for indeterminate beams to solve for the fixed end moment. Okay, so for this case, I'll just give you the formula for the fixed end moment. So the fixed end moment here is counterclockwise because the load is downward, and here would be clockwise. And the fixed end moment is P A B over L square. Both of them are P A B over L square. Kaya lang, one of this would be square. So the fixed end moment to the left is yung B ang i-square mo. Yung fixed end moment sa right, yung A naman ang i-square mo. Yan. So these are the fixed end moments whenever the concentrated load is not applied at the midspan. Okay? So applying this equation here, so therefore, the fixed end moment for BC, ito yun, sa left side, so that would be counterclockwise, so that would be positive. So positive, PAB square over L. So P is 40, A is the 3 meters, and yung B is the 4 meters, then square, all over L. L is 7 meters. So 40 times 3 times 4 square over 7. So that's 1920 over 7. Sorry, this should be square also. This should be square also. So this should be square. Sorry. Okay, so PAB square over L square. Ito naman, PA square B over L square. L should be squared. So from there, 40 times 3 times 4 square divided by 7 square. So this is 1920 over 49. So that's positive. Okay, so how about for the fixed end moment on CB? CB is on the right side. Right side is clockwise, so that would be negative. Negative PA square B over L square. P again is 40. A is 3 square times 4 all over 7 square. So 40 times 3 square times 4 over 7 square. So we got negative 1440 over 49. Okay, so these are the fixed end moments on member BC. Now, next is to write for the slope deflection equation or for the member end moments. Okay, so what are the member end moments? Let's start with AB. So member AB. Okay, for member AB, so we have 2AI over L. The length is 7 meters. Twice theta A plus theta B. Okay, minus 3 psi Okay, then plus the FEM on AB. Okay, so that's the member end moment equation for member AB. Since point A, joint A is a fixed support, therefore the rotation there is 0. Okay, now what is psi? What is psi? Okay, psi on AB, okay, psi on AB is actually equal to psi on BA. And that is, the psi here is delta over L. Okay? And since the rotation here is counterclockwise, so that would be positive. So that would be positive delta x, that's the delta x, over L. The L is 7 meters. Say 7,000 millimeters. Okay? So that is, this is psi for AB. Okay, so if we substitute it here, so this becomes, again, the fixed end moment for AB is 0 here. So this would be just 0. So what is left is 2 over 7 EI delta B, this one, then minus 3 times 2 is 6. So we have 6 over 7. We have EI psi, and psi is delta x over 7,000. Okay? That's one. Now, how about for member BA? For member BA, that is 2EI over L, again 7. Okay? Then, times twice theta B plus theta A minus 3 psi between BA plus the fixed end moment on BA. Fixed end moment on BA is 0. The slope or rotation at A is 0. And psi BA is also equal to delta x over 700. Okay? So this becomes 4 over 7 EI del theta B minus 3 times 2 is 6 over 7 EI psi BA. So this could be written as 2 over 7 EI theta B minus 6 over 7 EI delta x is actually the psi AB. So I'll just express in terms of psi first. Okay? Now, next. How about for BC? Moment on BC. So that would be 2 EI over, again, 7 meters twice theta B plus theta C minus 3 psi BC plus the fixed end moment on BC. Okay? Now, so wala rito 0. So when simplified, so this would be 4 over 7 EI theta B, then 2 over 7 EI theta C. What is the psi for BC? What is the psi for BC? Okay, the psi for BC is equal to psi for CB for BC. Since, diba the original point B is here, the final point B is there. Point C original is here, the final C is there. So, the relative displacement between these points B and C is just 0. Diba? Before and after loading, they're on the same level. So, therefore, psi there is 0 for that case. Okay? So, plus the FEM for BC is this, 1920 over 49. Okay? So, this is just 0. So, that is for BC. How about next for CB? 2EI over L. L again is 7 meters. Then, twice theta C plus theta B. Okay, minus 3 psi plus the FEM on CB. Okay, so when simplify, so let us simplify this one. This would be 2 over 7 EI theta C. Oh, sorry, 4 over 7 again. So 2 times 2 is 4. 4 over 7 EI theta C plus 2 over 7 EI theta B. Then again, this is 0. The displacement of point B and C relatively is 0. Plus the FEM on CB, which is negative 1440 over 49. Okay, so that is for CB. Next is for CD. Moment on CD is again 2EI over the length for CD is 5 meters. So 5 twice theta C plus theta D minus 3 psi for CD plus the fixed end moment on CD. Okay, so simplify. Joint D, support D is a fixed support, therefore the rotation there should be 0. Okay, so the psi here is meron because there is deflection here on C, that's delta X. And the fixed end moment for CD is actually 0. So when simplified, so this becomes 4 over 5 EI theta C, okay, minus this one is 6 over 5 EI psi on CD. Okay, psi on CD. Now, what is psi on CD? Actually, psi on CD is the same, different, no? Kasi the length is different, but the delta would be the same, delta X then. Okay, so lastly, how about for MDC? For MDC, it's 2EI, again, over 5, twice theta D, plus theta C, minus 3 psi, plus the fixed end moment on DC. Again, fixed end moment DC is 0. Then, the slope at D is 0 also. So, this becomes 2/5 EI theta C, then minus 6 over 5 EI psi for DC. For psi DC. And psi for CD is just equal to psi DC, right? Okay. So, let us simplify. Okay, so let us simplify. Okay, so let us replace but again, the psi for AB is equal to psi BA, and that is positive delta X over the length is 7,000. Okay? 7,000. Assuming that delta is expressed also in millimeters. Yung psi naman sa BC is equal to psi naman sa CB, and they are just equal to 0. While yung psi naman sa CD is the same with the psi sa DC, and there's equal to positive delta X over L. The length for CD is 5 meters, or in millimeters, so that's 5,000 millimeters. Okay, so substituting this psi value in the equations, okay, so this would be for MAB, so this is the simplified equation. It would be 2 over 7 EI theta B, okay, minus 6 over 7 EI psi AB. Psi AB is positive delta X over 7,000. Okay, so this becomes 2 over 7 EI theta B. Then when you simplify this would be 6 over 7 6 over 7 divided by 7,000. So this would become 3 over minus 3 over 24,500, okay, EI delta X. Okay, how about for BA? Moment on BA. So ito yun, no? So it would be 4 over 7 EI theta B, then minus, what is psi BA? Psi BA is this one. So that would be the same, no? So minus 3 over 24,500 EI delta X. Next, how about for BC, MBC? MBC is this one, so I'll just copy it. 4 over 7 EI theta B plus 2 over 7 EI theta C plus the 1920 over 49. Then for CB, this one, so I'll just copy the same lang. 4 over 7 EI theta C plus 2 over 7 EI theta B, then minus 1440 over 49. Then for CD, this one, for member CD, okay, for member CD, ito yun. So 4 over 5 EI theta C minus 6/5 of EI, and psi CD is ito. So that would be minus 6 over 5 times psi, ito. So divided by 5,000, so that becomes 12,500 EI delta X. Okay, then last would be MDC, this one. So that is 2/5 EI theta C minus 6 over 5 of this one, psi DC. So it would be 3 over 12,500 EI delta X. Okay? So, from this set of equations, substituting the psi values, it gives us these equations. So, equation 1, 2, 3, 4, 5, 6. So, what's next? So, applying equilibrium equation or compatibility equations. So, anong alam natin dito sa joint B? Hindi ba sa joint B, the moment there should be 0. The summation of moment there should be 0. So, that means MBA when added to the moment on BC should be equal to 0. Okay, so that would be this one, BA and BC. So when we add these two, the sum of these two should be 0. So if we do that, okay, so let's add these two. So this would be 4 over 7 plus 4 over 7. So that's 8 over 7. No? So 8 over 7 EI theta B, then this one plus 2 over 7 EI theta C, then this one minus 3 over 24,500 EI delta X, then the constant plus 1920 over 49. Okay? Should be equal to 0. So from this equation, we have three unknowns, theta B, theta C, and delta X. Okay. So what else? What compatibility equation pa? So likewise, at joint C, diba? So if it's some moment at joint C, the summation should be also equal to 0. So that means the moment on CB, when added to the moment on CD, CB and CD should be 0. So CB is here and CD is here. So when we add these two equations, what will happen? So this is 4 over 7 plus 4 over 5. Okay? So that's 48 over 35. That's EI theta C. Okay? Then we have theta B there. Plus 2 over 7 EI of theta B. Then this one minus 3 over 12.5 EI delta X. Then this one minus 1440 over 49 should be also equal to 0. So as you can see from this equation, we have unknowns theta C, theta B, and delta X. So we have three unknowns, yet we have only two equations pa lang. Okay? So we need to generate another equation to solve for these unknowns, three unknowns. So saan manggagaling yung last third equation? Okay, so we will be having the third equation from statics equilibrium. Okay, so for the third equation, so this is for the third equation. So let us isolate member AB. Okay, so looking at member AB here. So here is member AB. Okay, so fixed. So this joint, so we have so okay, so we have here the moment on BC. while this one is the moment, sorry, on BA, sorry, this is on BA, this is moment on AB. Then of course when we cut joint B, so there will be a shear there, shear, and there should be axial. Okay, here also it would be, there will be a shear also here, say shear on AB. Ito naman yung shear on VA. Okay, so then this is 7 meters. Let's say summation of moment ako. Summation of moment ako sa point B. So statics. So I'll have what? Negative MBA, then negative MAB. Let's say this is to the left, so plus VAB times 7 should be equal to 0. So therefore, I could say that the shear on AB is just equal to MBA plus MAB over 7. Okay, so that's for shear on AB. And hindi ba't yung shear on AB na to is actually equal to the reaction at point A, X. That is the reaction horizontal at fixed support at A. Okay? Now, how about for member, let us now isolate, ito naman, CD. So almost the same, okay, for member CD, this is point D, here's point C. So these are the end moments. So this is the moment on DC. Ito na may moment sa CD. This is 5 meters. Okay, of course may shear din dito. The shear on DC, ito rin may shear naman dito ng CD. Plus may axial din yan. Okay, but if I sum moment at C equal to 0, take moment ako rito. So I'll have negative MCD. Tapos yung moment dito, negative MDC. Then yung shear, positive shear DC, moment arm is 5, should be equal to 0. So therefore, the shear on DC is just equal to MCD plus MDC over 5. And that shear DC is actually the same with the reaction at D, horizontal, say DX. Okay, now, what is the relationship of DX and AX? So, hindi ba considering the whole structure or the whole frame, there's no horizontal load applied at this frame. So the horizontal force acting on this frame would just be coming from the support reactions at A and horizontal support reaction at D. So if we sum forces horizontal equal to 0, dapat the AX when added to DX should be equal to 0. Summation of forces horizontal for the whole structure should be 0. So, substituting AX here, AX is this, and AX is this one. So, we'll have MBA plus MAB over 7, that's AX, plus, what is DX? DX is this one, MCD plus MDC over 5 should be equal to 0. Okay, so with this we will use this to be our third equation again. So this is our first equation, This is our second equation. And this would be our third equation. But yung first and second equation natin are expressed in terms of theta B, theta C, and delta X. So, ganun din gagawin natin dito. So, we have to express these moments in terms of thetas and delta. So, saan natin kukunin yon? So, dito. Okay. So, substitute natin. So, it would be MBA is this one. And MAB is this one. So, we're going to add these two. We're going to add these two. Okay. So, what will happen? So, 2 over 7 and 4 over 7 is actually 6 over 7. So, it would be 6 over 7 EI theta B. So, this one. Then, these two, we're going to add. So, it would be 6. Tama ba? No? So, it would be so MBA plus MAB. So, we have to add these two. So, the same. So, it would be 6 over 7. This one, it would be 6. So, minus 6 over 24, 500 EI delta X. Okay? So, yun. Divided by 7. Plus MCD. MCD is here. And MDC is here. So, these two. I'm going to add them. So, that would be 4/5 plus 2/5 is 6/5. EI theta C. Then, I'm going to add these two. So, that would be minus 6 over 12,500 EI delta X. Then, divided by 5 equals 0. Okay? So, simplifying this, so this would become 6 over 7 is 49. 6 over 49 EI theta B. Then, this one naman is 6 over 25. 6 over 25 EI theta C. Then this EI delta X, I'm going to add them. So then negative 6 over 24 500 divided by 7. Then minus 6 over 12 500 divided by 5. So it becomes negative 1.3098 times 10 to the negative 4. Okay, so that's AI delta X. Okay, equals 0. So this would be our third equation na. Okay, so we're done. So first, second, and the third equation. So we have 3 equations with 3 unknowns. So, solving simultaneous equation. Solving simultaneous equations 1, 2, and 3. This would give us the answers for EI delta B. And that is negative 40.14. EI delta C 3419, and finally for EI delta X it's 25,000, okay, 112.40. So these are the answers for the 3 unknowns. Then substituting all this, substitute in member and moments. So this would give you, so here, if you substitute this values theta b, theta c, and delta x on these equations, it would give you the answers for the member and moments. And these are, so let me write it here. So the moment on AB, negative 14.54. Okay. Member BA, moment on BA, negative 26.01. Member BC, that's positive 26.01. Member CB, moment on CB, negative 21.32. Then moment on CD should be positive 21.32. And last is yung moment sa DC is 7.65. Okay? So these are the member and moments. Then for the support reactions naman, you just have to apply for support reactions. So let us apply at statics. Okay, so applying statics, the support reactions would be AX would be 5.79. That's kilonewton, which is directed to the right. And of course, yung dx naman would be the opposite. Okay? 5.79 din to the left naman. Then for the vertical reactions naman, for AY, this would give us 23.53 kilonewtons, and that is upward. Then for support at D, the vertical component would be 16.47, and this is directed also upward. Okay, so how about the moment at A? The moment at the support reaction A is actually the MAB, right? So which is 1454. So 14.54. Okay, so that's kilonewton meter, and the direction is clockwise. Because this is negative, so that means the assumed direction, which is counterclockwise, is wrong. So it should be clockwise. How about the moment at D? The moment at D, support D, is actually the same with the MDC. And the MDC is positive 7.65. So that would be 7.65 kilonewton meter. So positive, that means it has a correct direction, which is counterclockwise. Okay? So these are now the support reactions, the horizontal, vertical, and the moment reactions. Okay, so I hope you learned something out of this example. So again, this is an example of a analysis of frames with Sidesway using slope deflection method. So thank you and have a good day.